So I started the recording a little late, but we are doing some practice of 2-6, the back of your homework. We're doing those three together. I'm gonna start by being quiet so you guys try and do those by yourself. But I do want you to see though is over here, we made a list of all the things you need to do when you graph these. So if you don't remember this, or if you need a screenshot, or if you need to take a picture or write it down, just pause the video. Do those 6 things every time you set up a problem. Okay? Pause it. I'm gonna keep. So when I have something to say, I'll bring it back together, but right now I'm gonna work by myself. Okay, why is it the 4 on that first one?
Isn't it +8?
Oh, plus it. Is it -4? Okay. -4. Okay, that makes more sense. Okay. I'm gonna pause you here. Hopefully you've done up to this point. Did you notice something a little bit funny about this graph? Okay, I'm gonna tell you we're doing these 3 examples. They're not the most perfect examples, so I want you to take it all with a grain of salt. I've got something weird happening here. Do you see that I have a intersection on my horizontal asymptote? Okay, this is something I just was talking to Miss Ludington about because normally I don't like play this game or talk about this much at the academic level. But technically, a horizontal asymptote is like an end behavior asymptote. It really is something you just approach at the end. Technically, you can cross a horizontal asymptote. You don't do it a lot, but technically you can. However, when you get a vertical asymptote, that's something you never, ever, ever, ever cross. So this is not something I would quiz or test you on, but technically rational functions can have a point that crosses that asymptote, okay? So as we look at this, I'm still gonna graph like I'm used to. My bottom in here, I can't cross these vertical asymptotes, so I'm just kind of approaching it. I think it should go a little bit higher than that y-intercept just because it doesn't look fully centered. But again, it's a sketch. So if you had that as your highest point, it doesn't matter. It can go as high or as low as you want that to, as long as you hit that point and you're going down, you're hugging your asymptotes. That top right quadrant, I'm just going to hug my asymptotes because I don't know any better or any different. But on the top left one, I'm going to hug my vertical asymptote and I am going to cross that horizontal, but then I'm going to stay tight to it because again, my end behavior has to stay tight to that asymptote. Okay, it has to stay tight. Now, again, I will not put that on a test or quiz. Okay, so I'm so sorry. It's a weird example, but I think we're allowed to talk about it. Okay. Did you guys get every other piece right? Your vertical asymptote, horizontal asymptote, x-intercept, y-intercepts? All right, should we go look at the second one? All right, I'll leave this up for a second. You start the second one. I'll join you momentarily. Got all my work over here for the second one. Do you guys get the same vertical asymptote, horizontal asymptote, x-intercept, y-intercept? See when I plugged 0 in for all my x's, I got a 0 in the denominator. That's undefined, you can't have that. And that also makes sense because my vertical asymptote is at 0. And as we talked about, horizontal asymptote's weird and iffy, but the vertical asymptote you cannot touch. So it makes sense I don't have a y-intercept. Let's put it all together.
You can draw the holes on the graph.
Mhm.
Or an open circle, right?
So it's an open circle at -2. So it's over here somewhere. It's probably right about there. It's actually something I also need to talk to Ms. Lennox about that I haven't talked about. You can actually find the value of the whole. I feel like we talked about it in class the other day. I haven't made you do it yet. I probably should figure out if I'm going to. But you could plug the value that the whole is into the simplified equation and it will give you the y value. So in this case, -2 minus 2 over -2. -4 or +4 over -2 is -2. So that makes sense. I put it maybe a little higher than it should be, like right about here. Anyway, I'll keep that up if you're still looking. And then why don't you guys go on to number 3? That horizontal, that slant asymptote is going to be weird, but we'll talk about that in a second. If that scares you, do everything else but that. That scares you, do everything else but that. Before we do horizontal asymptote, did you guys get everything else that I got? I think those are pretty self-explanatory. Horizontal asymptote, this is one of our synthetic division ones, right? My exponent on top is bigger than the exponent on the bottom. Generally, I want you to use the new version. That being said, this exponent out front makes things a little bit funny. So we're just gonna pretend like that doesn't exist. And again, this is like a thing that I wouldn't test you on, okay? If I test you, and I'll give you an example on Monday, there would be no coefficient in front of that value, okay? So I wouldn't stress out about it, it's just whatever the bottom is. So we're gonna just treat it like inside my house is -3. Is everybody okay with that? It's gonna be a little different than what the actual answer is if you plugged in the calculator, but this is gonna be good for now. And then we're gonna use the simplified top, so we're gonna use 1, -1, -6 to do my synthetic division. Everybody aware of where I'm at right now? Everyone's okay? All right, do your synthetic division, find out what graph that's going to give us. And then once we have that, we can do all the pieces all together. My slant first. You would find out exactly where that hole is, I can plug it in,
I didn't get the word.
cancel factor. So I've got -6 over -12, I think it's 1. Should be +1/2. I'm not sure where I'm messing up, so we'll just say so. It probably doesn't work because I changed the rule earlier, which means that it's not gonna do what I wanted to do, so that's good enough for now. I got more like this on Tuesday that we'll practice. You guys good? Okay. I know those were 3, like, not the best examples, but they work well enough. We practiced kind of going through the methods. This is something you just gotta know. Okay, if you are now done with your homework, can you make sure your name's on it and pass it forward? I will collect that now, and then we're gonna do like just a few problems of notes. Your 2-7 will be due next class. We probably won't get to the last word problem, but it's not on your homework, so I'm okay giving you homework to complete this weekend. So 2-7 is due next time I see you. 2-7 is due next time I see you. That's for me too. 2-7 is due the next time I see you. Okay, so flip over to your notes. We just got a couple word problems. They are pretty weird, but we can work through them. It's a lot of plug and chug today, which I always find pretty nice. And it's none of these are graphing calculator problems exclusively, but you may want your calculator because we're going to deal with some kind of funky numbers. So first thing I've got is this problem number 7. So find me on number 7. In error. You don't have enough numbers. There's other numbers in here that I mentioned. So one more pair in there. See if you can find it.
I'll be doing 50 problems.
All right, this one says Midtown Sports Apparel Inc. has found that it needs to sell golf hats for $275 in each in order to be competitive. It costs $212 to produce each hat, and it has a weekly overhead cost of $3,000. So whether they sell one hat or whether they sell 1 million hats, it costs $3,000 a week just to like run their business, rent their office space, whatever you want to call it. Okay, it says let X be the number of hats produced each week, express the average cost, including overhead of producing one hat as a function of X. Okay, so we're gonna write an f of X equation. Now, first off, it tells us exactly how much it costs to make one hat. How much does it cost to make one hat? 212. So we're gonna say 212X. But we also have to deal with the overhead. So I'm gonna say plus my overhead. How much was overhead? 3,000. So regardless of if I make 0 hats or 1,020,000 hats, I have to pay $3,000. And since I want to do it per hat, not every hat is that $3,000 over. It's like that in addition to how many hats we make divided by by just one hat. Okay, so we're going to divide by one hat because we want to find the product or the average cost of one hat. Okay, so it makes a rational function. Is everybody okay with that? Also, don't panic. I'm not going to do a question like this on your test, okay? But just everyone's cool with what I've done right now. Now it says solve algebraically to find the number of golf hats that must be sold each week to make a profit. Okay, profit means what? More than what we spent, right? So we want this number, and then right now it tells us we're selling hats for how much? $275. So if we set this up, we can just set it equal to 275, and it will tell us how many hats we need to just be exactly even. Maybe make a tiny bit profit, but not be negative, okay? So we're just gonna set it equal to how much each hat is right now. Okay. How would I go about solving this? What would I start to do? Multiply by X, get rid of that X. Then I've got 212X plus 3,000 equals 2.75X. What do I do next? Get the X's on the same side. That's 0.63X. And then what's the last thing I need to do? Divide.
So solve that by putting that in a graph.
You could. But you're gonna see our answer in a second. And it's a giant number. So X is equal to 4,761.9 hats. So you could graph it, but it might take you a long time to find out where they intersect. Okay, can I sell 0.9 of a hat? No. Am I gonna round down or am I gonna round up? We're gonna round up. I have to sell that 0.9 hat to get equal to that 2.75. So I'm gonna round up. I need to sell that actual whole hat in order to make a profit. So 4,762 hats. Okay, my next part of this question says how many, it should be golf, how many golf hats must be sold to make a profit of $1,000 in 1 week?
So just equal to
Equal to what?
2,000 instead of 270.
No, because the 275 is how much each hat costs. Where can I add in that I want to have more of a profit? Right now we have price per hat plus my overhead divided out equals the cost. Where can I add that 1,000 into? Have an idea? I'm gonna add it into this 3,000. What if I make that number 4,000? So I'm pretending like it takes me $4,000 to make these hats, which gives me an extra $1,000 of wiggle room. Does that make sense?
Mm-hmm.
It also makes sense that that's the number that like we would combine it with. I'm not combining it with the price. I'm not combining it with how much it costs. It's not going on the bottom with the X. That's the only number that it's kind of close to. So instead, the only thing that's different from the problem we just did to the problem I'm doing now, my thing wants to work. There we go. Is instead of 3,000, we're gonna write 4,000. And then you can actually probably solve that pretty quick. Same process as before, almost identical numbers. But now I'm not dividing 3,000 by 0.63. I'm dividing 4,000 by 0.63. And 4,000 divided by 0.63 is a lot bigger. 6,349.2. And I am also gonna round up because I need to sell that 0.2 of a hat, which means I need to have sold the whole hat. So I'm gonna make it up to 6,350 hats. You guys okay with that? Okay. Can I flip it over? Can we do two more? I bet we can. Right. Now, this next one's even better because it gives us an equation. We don't have to write it. The number of bears at any time, T in years, in a federal game reserve is given by this. P of T equals 500 plus 250 T over 10 plus 0.5 times T. Okay. It says find the population of bears when the value of T is 10, 40, and 100. How would we find the population? Plug it in. You want to take, let's share the burden. Girls, can you plug in 10? Boys, can you plug in 40? And then I'll plug in 100. And then we'll share the work, okay? I actually had a little bit of a problem plugging this in earlier today, so make sure that you know how to plug it in the calculator and see if you'll get the same answers as me. But the reason I had problems might be a personal problem. You might be fine. All right, I plugged in 100 and I got 425. When you plugged in 10, did you get 200? Perfect, then you did it well. When you plugged in 40, did you get 350? Good, okay. That might sound so silly, you might be like, Miss White, I know I can plug in the calculator. I have a degree in math and it took me like 2 minutes to get that earlier today because I like kept mixing up, I kept making silly mistakes. So just make sure you're careful, watch yourself on that. So make sure you know how to plug it in. Now, does this graph of the bear population, does it have a horizontal asymptote? Does it have a horizontal asymptote? Yeah. Why do you know that?
Because you should care.
Because what? Okay,
Please.
because I've got T's. What kind of equation is that? It's a fraction, and what have we been calling those? No, not linear. Reciprocal is a word. What have I been using also this week? The other R word, rational. You guys remember here, I said rational?
Yeah.
So yes, it's a rational or a reciprocal function. Those words are the same to me. So it does have a horizontal asymptote. How would I find the horizontal asymptote here? Look at my T's, good. Are my T's the same or is one bigger or smaller? The same, so then what do I look at? The leading coefficient, so it's 250 over 0.5. Can we figure out what that number is? Not 5. I think it's 500. So it has a horizontal asymptote at 500. Cool. That was just plugging in. That was finding for a horizontal asymptote. We good so far? Can we do one more? This one, they also give us a equation. Now, I'm going to be very honest. I don't know like 90% of the words in that problem. And that's okay because they gave us an equation. The total electrical resistance R of two resistors connected in parallel with resistance R1 and R2, those refer to resistance. It's given by this equation, 1 over R equals 1 over R1 plus 1 over R2. One resistor has a resistance of 2.3, and let X be the resistance of the second resistor. Okay. So I have my equation. I don't need to take anything out of R because it says express the total resistance as a function of X. So I'll go 1 over R equals, what did they say the first resistor's resistance is? 2.3. And then what did they say the second one was? X, very good. Does this kind of look like the problem we were doing yesterday? Do you remember what those were called? Those word problems? What did we write at the top of those word problems yesterday? The work word problems. Remember that? When we were doing the pool and then the painting. Yeah, 1 over alone, 1 over alone. This is the same idea. 1 over alone, 1 over alone, 1 over together. Okay, now we're going to take that equation that they gave us. It says find the resistance of the second resistor if the total resistance is 1.7. So where do I put 1.7 in my equation? R, very good. 1 over 1.7 equals 1 over 2.3 plus 1 over X. That looks like what we were doing yesterday, doesn't it? And then we'll multiply. And I'm not even going to factor it out or multiply anything together. I'm literally going to do 1.7 times 2.3 times X. Because when I simplify, it's going to be a little bit easier. So the 1.7s will cancel. So that first one will be 2.3X. Good. Equals 1.7X. Good. And then now you know on the last one, you got to multiply together finally. So 3.91. And then just like we were doing earlier, can you get your X's together? Divide to get X all by itself. It's 6.52 OHN. I'm gonna tell you, if I was an engineer, I would know what OHN stands for. But instead I studied education, so I don't know. All right, that's all I got for you guys. We feeling okay? Okay, I'm gonna turn this off. 2.7 is due tomorrow or next class.